They have 1 kilogram as a weight of 2.205 pounds. I crossed that out in mine. That is making an assumption that you're near the surface of the Earth at some generic place. We are not, in physics especially, we are not necessarily near the surface of the Earth, and so that is not a valid, that's just not valid. All right, so my mass is about 100 kilograms, and I need to figure out what my volume is. What is my density? Approximately. I assume more than one person in here has been swimming before. If you want to sink to the bottom, what do?
Don't move.
That's all you have to do?
Let the air out of your lungs.
Yeah, and if I have air full of lungs, am I going to sink?
It's going to be harder.
Yeah. So the difference between my sinking and my floating is I float, I sink. That's not a whole lot of difference there. So that puts my density roughly that of water. So I have my 99 point, let's try that again. My density is approximately equal to 1,000 kilograms per cubic meter. Lost a zero there. And that's going to be my mass divided by my volume, and my mass is 99.89796 kilograms over my volume. So one there. So what is my volume? The math problem we're working with here is I have 1,000 over 1 is equal to 99.9 over, that's the math problem. Ashley, do you have an answer? Not that you're confident with? But I do you have an answer?
Not confident, 10.01.
10.01?
Yeah.
Something's off there. I think you
Flipped it.
flipped it. Units? Cubic. So roughly 0.1 cubic meters. So now the question is, how many of you would fit in here? Because I would fill it up to about here. If you take the reciprocal of that, which one I conveniently had just done, about 10 of you would fit inside that. In theory. The thing is, if we're actually tested, I would never know. So, a number of years ago, Hurricane Floyd, the one that sort of stalled off the coast of North Carolina back in 99, I think it was. Whichever hurricane that was. And my brother commented on Facebook, they're getting hit by a ton of rain. So naturally, I wondered, how much actually is a ton of rain? So a ton, how big is a ton?
Is it 1,000 pounds?
What did you say?
1,000 pounds?
Not 1,000.
2,000?
Yes, 2,000 pounds.
Close.
All right, so a ton of rain would be 2,000 pounds. All right, so let's figure out what that is in newtons. We just did the problem over there, basically this times 4.45.
$8,900.
8,000.
Oh, no, 900, 8,900. 8,900, 8,900.
And then to figure out what that mass is, so then we would, if we divide by 9.8 meters per second squared, that will give us the mass.
908.16.
One more time,
908.16.
kilograms. I know that 1,000 kilograms is equal to a cubic meter. 1/6 kilograms, figure out what that volume is, and that should have the same density as 1,000 kilograms per cubic meter. And so we end up with this ton of rain is 0.90816 kilograms. I put too many decimals in there. No, that should be a 1. Oh, wait, that's volume, cubic meters. So given that box that we had, and then out to here, it fills it up to about somewhere around here. So, with much love, I replied to my brother as, that's about 3 bathtubs full. I guess you're saying to get a light sprinkling. Because what are brothers for other than to take apart what you say on Facebook or whatever your social media choices?
Did you ever figure out how much rain it actually fell?
No, it's a lot more than a light sprinkling. I do know that. Yes, Chase.
Why can we not, I know we're not supposed to, but why can we not just convert 2,000 pounds to kilograms? Like, why do we have to go through it?
Officially, when you're doing a conversion, you're converting from a unit for a quantity into a different unit for the same quantity. Newtons and pounds are units of force. Kilograms is a unit of mass. They are 2 different objects. And the conversion that is presented in the book and that you might see elsewhere is making the assumption that you're in some generic place on Earth. And in physics, we just don't want to make that assumption that you have to be stuck here. In biology, I guess you get away with it unless you're doing exobiology. Exo, the outer possible life on other planets. Well, we can just go with that unless someone's going to correct me. Unless, of course, you're doing exobiology, then. All right, so now we've got some handling of density. So let's talk about the other big topic that covers all the states of matter, pressure. What is pressure from a physics point of view or chemistry point of view? Let's say physics, because we'll get into that story in a moment. Anyone in here stepped on a nail before? Besides me? Okay, got a couple of people. I assume it hurt. Have you seen people lie on a bed of nails?
Yeah.
Why did they not get pierced?
Because there's multiple ones.
Yeah, so what changed?
They were spread out.
So whatever pressure is, it has something to do with how much it is spread out. So pressure is divided by the area. So the more nails that you have, and especially if you've got dull nails, and the people who, I think, do this for show will hammer the top of all the nails to make the heads a little bit blunter. And then it's force. It's force per area. So as I am standing here, I'm exerting pressure on the floor. I'm exerting a force on the floor over a certain area. So let's calculate what that is. I know that the force I'm applying to the floor is my weight. Well, technically not. The force I'm applying to the floor is the normal force, but if I'm just standing here in equilibrium, the normal force equals my weight. So the force I'm applying is, we just did it, 979 newtons, I think it was. Point, somewhere around
Yeah,
there.
979 meters.
Okay, now the area. Area spread out over 2 of my feet. Do a quick crude measurement. And pretend my foot is a rectangle. So it's roughly 0.3 meters that way, and about 0.12 meters this way. So what is the area of my foot? Or how would you find it? Did you just say something, Jason?
I said multiply.
Okay. And we end up with 0.36, no, 0.036 cubic meters. And I have 2 feet, so we multiply times 2. So if I take my almost 1,000 newtons and then divide it by 0.072, what do you get?
Why does it keep it? Why is it, it's square?
Oh, it should be. Thank you very much. Squared. That should be squared. Glad one of us is paying attention. All right, so
I get confused.
what do we get? Attention mounts.
$13,597.
13,900.
597.
597.
And 0.2 repeating.
Units?
Newton meters?
Yep. But you did mention 2 of the key ingredients there.
Newton meters cubed. Or square. Sorry.
All right, so just look at the, right here, we have in the numerator,
Newtons.
Ashlyn, what'd you say?
Newtons times a meter squared.
Not times. You might have just said it, I can't quite tell. My hearing and your softness were,
Newtons, so a meter squared.
say it again?
Divided? Is it divided?
Yeah, you're dividing right there, so it's newtons per square meter, or meter squared, whichever way you like. Now, this is obviously a lot to write. Do I really have to write all those letters for the units? And they said, you know what, instead of writing those 2 letters, let me give you 2 different letters to write. This is also, when dealing with pressure, this is also known as a Pascal. So 100, just rounding off, 13,600 pascals.
Capital P?
Capital P, lowercase a. Anyone want to take a wild guess who they named it after? If you've heard of Pascal's triangle, same thing, same guy. Pascal's principle, which we'll get to Thursday probably. Blaise, I think it's Blaise Pascal, B-L-A-I-S-E, not with a Z. So, obviously, if I stood on your skin, so your arm's out like this, and I stood on top of it, I'm not gonna puncture your skin. The pressure is spread out, it's not gonna do it, but there is a point at which your skin will basically break. There's an optimum pressure. So the question is what size heel would I have to wear in order to be able to puncture your skin? Yeah, this is, I understand. I've done a number of morbid examples here. It's just fun, right? So for you future assassins out there, you have some idea of how to apply physics to your job. But that will presumably wait. So we've hit the fundamentals there. I'm gonna be, by the way, I'm doing 11 through 14 relatively quickly. What I do for the assessment on that one is different than I do for the other stuff, than other chapters. So, well, I guess Thursday, potentially finish up 11 through 14 and then talk about how I treat it differently. And then we'll get into the content for the last test. Pardon?
You only
Yep.
have one more test?
Well, no, there's, you know that multiple choice test you did the first day? Yeah, you get that one again also.
Oh, this is the same thing?
Yeah.
There's that feedback.
That counts, yes, that's one of the three tests.
Oh, we only have 2 more tests that are in the station.
Yes. One's the multiple choice thing, and then the calculator one is the material that we start after this.
And those ones, those last 2 will have test corrections as well, as like the first one?
No,
Oh.
because the last tests will be on the last day,
Oh, okay,
and the multiple choice test, I don't do right now.
right. Okay.
Have a good day.
Yep, you do.
When is the last day?
The